Okay, the first time I forgot the time, so I have to do this again. Okay, this is a layout of this BOM post header, and I use a header on top and then put all the stacks here and which next to each other, and then all the frames behind the other stacks here. Each frame have a pointer point to its previous one and the next one. The previous one of the first one is null, and the last one in the first stack, it should be null. And all the others point to the previous or the next one. Okay, and all the frames in the, even though they are connected to each other, but they may be separated by the number of frames in each stack. So this one is the first stack. Here, from here is the second stack till here. And this is the last stack. We usually have 3 stacks in our FBX file. And after all the frames are done, are the bones. Each bone part have 20 bones in it, in the teddy file, and 80 in the humanoid file. And they are all connected with each other. Because they are all connected, so they don't have any pointers. And each of them have TQS. And here, okay, yeah. And for example, this part is the first are the bones in the first stack. Each one is each of the frame have pointer point to them. For example, there's the third one point to the third bones, and the last one should point to the last one here, for example. And all the bone values are laid together next to each other. Okay. And I don't know if I have showed you that in the first video, but I want to show it again here. Well, the math part, the quadrant part, I calculated it from the original value and saved it tempo bone. And the transition and scale part kept the same, but I also copied it to the destination and then put it to vector. Okay, and the main part, when we save the bone pose, first we initialize the header and all the offsets, calculate the bone offset and everything. We create a new vector called anything to write, for stacks to write, and here frame to write and bones to write, and write all the old values to the new vectors. And we correct all the pointers in the bone frame, and this is the pointer pointing to the bone. Here, just the bone values, we copied everything from the old one to the new one. So I don't have to do it here, but I want to use the new values just to keep it bugless. And after everything is done, we just put it in a big, huge memory, and then load it in place to the file. And here, I use the search to, I use the teddybear.b FBX to start, so I assert all the values with the teddy values. So I just run it, show everything should work. Okay, no compile errors. So that means our writing part is good. Our writing part is good, but the reading part is also very hard, and I will tell it later in the engine file. Okay, great. And okay, and when we write the file, because we have different blocks of the buffers here, and so I created a new header of all the headers. The new header just have some offset pointing to, okay, which part should this block start and which part should this block start. I write the headers first, then I write each block of values into the file. Even though I write it 4 times instead of 1 time, but it's much less than 1,000 of times writing to a file. Okay, and everything is done here. Okay, and we just run the .bat file. I believe I have showed that before. Okay, it's done, and we can find the file in the test. Okay, this one just when I run the compile to test value, these are the 2 final outputs. So the name of it should have dot in it. That's a problem. So everything are in the same file output. Everything I lay out here, and what we want to use are the 2 visual files, and copy it to PA5 source file, and here. Okay, it should be there. Okay, and next I want to show the game engine, the animation. Okay, these are the animations. Just run it and test. Okay, great. And in the animation, I want to show first is here the memory track path, nothing leaks, and just extra output here. Here, trace out. Okay, so nothing leaks, and in the set part, when I set hierarchy and set pose, set one pose. Okay, no, set pose. Okay, never mind. Okay, when we set the hierarchy, we read the file from the from here, load everything to a buffer, and return this buffer to here. So the beer buffer holds all the values in the beer file, and the human buffer holds all the values in the humanoid file. And also, I just, because I have a header of a header, so I can easily find which part is the value. So in this assignment, we only use the hierarchy part and the pose part, but not the review part. So I find the header of them and set animation based on the header, the hierarchy and the data based on header. So okay, the first part is the same as the given project with until the rigid node. And on the second part, the first one is a little bit noisy, but okay. Because the bones have 2 bones that we don't want to write, we don't want to show, so they are dealt separately. And all the first nodes will add to their parent is rigid, so we won't generate from the binary file. So we have to deal with that differently. So that makes the bone we should start with 2, but the humanoid we should start with 1 to correct all the pointers in the file. So I just create an offset, yeah, in the bones 2 and in the humans 1. And when we iterate from the out memory, we do